Next, we're going to be doing the Friedel-Crafts acylation. This is in comparison to a Friedel-Crafts alkylation. They use the same catalyst, the aluminum chloride catalyst, but different organic starting materials. So a Friedel-Crafts alkylation uses an alkyl chloride of some kind, and it has some very distinct limitations. So the alkyl chlorides, when you do the Friedel-Crafts alkylation, can rearrange, so give you some undesired products that way. You are also adding an activating group onto the ring after you have added the alkyl groups. So alkyl groups are mildly activating for electrophilic aromatic substitution. So Friedel-Crafts alkylations are generally out of control. Once you've added one alkyl group, if you have more room around the ring to add another, you will, and continue going until you have filled up all the spaces around the aromatic ring. The Friedel-Crafts acylation was designed as a way to get around the problems of the Friedel-Crafts alkylation. So instead of using an alkyl chloride, you're using an acid chloride or an acyl chloride to do one substitution of the ring. Now, the reason why this reaction stops at one substitution is you are adding in a deactivating group. So any group that has a carbonyl attached to the aromatic ring is a deactivating group. So we call that electron withdrawing group. Electron withdrawing groups are deactivating, electron donating groups are activating. And you can compare this to the previous experiment, to the relative reactivities experiment, to see the differences between the two. So we're doing the acylation. You are only going to add one acyl group to the ring. You are going to use the spectra that we give you to determine the product from your starting material. So each starting material is going to give a slightly different product. We are still going to be following the activating and directing rules. So the starting materials that we're using, if you look at the groups that are on those starting materials, they are all a specific kind of director, an ortho-para director. So make sure that you don't consider any products that are going to be meta-directing. I know sometimes that the spectra can give some, multiple suggestions, but make sure when you consider the possibilities that you don't consider any meta-directors. So key here is you determine your final product using your spectra, and like in the previous experiment, it's only when you decide what your product is that you can do the percent yield calculation. So make sure you do things in the proper order.